Hello students, in second PUC chemistry, question paper part E contains problems, numericals related to physical chemistry. So in physical chemistry there are three chapters: solutions, electrochemistry and chemical kinetics. So from each chapter in annual exam you will get two problems or two numericals from each chapter. You need to attempt any three minimum questions you need to attempt from this part E section. So if you are perfect in any two chapters also, you can able to manage this section in annual exam. So in this video we will see the most important formulas from each chapter and some important problems in this video. The important formula from solution chapter is from relative lowering of vapor pressure. So from relative lowering of vapor pressure, they will ask you to calculate molar mass of solute. So molar mass of solute, we need to rearrange the formula like this to find out. Then second important formula is elevation in boiling point or ebullioscopy. So here also this is a main formula. If you remember this formula, if they ask molecular mass, you can use this formula. And if they are asking elevation in boiling point delta TB, use this formula. If they ask mass of solute WB, use this formula. Sometimes they may ask you to calculate Kb, ebullioscopic constant Kb. So that time you need to use this formula. The third formula from this chapter is depression in freezing point. So from depression in freezing point, this is the formula. They'll ask you to calculate the molar mass of solute or delta TB or cryoscopic constant Kf. The fourth formula is osmotic pressure pi. From this formula, they'll ask you to find out the molar mass of solute. Then some of the other important formulas of this chapter are Henry's law formula. Either they'll ask you to calculate the pressure, mole fraction or Henry's law constant. You have to use these formulas. Then mole fraction of solute Xb. So this is a formula to find out the mole fraction of solute Xb. And to find out the number of moles of solvent and number of moles of solute, you need to divide mass with molar mass. The second chapter from physical chemistry is electrochemistry. From this chapter, the numericals comes from the formula Nernst's equation. From this formula, you will get 3 marks question. And another important formula is relationship between standard EMF and equilibrium constant Kc. And another formula is Gibbs free energy change delta G naught and cell potential from this formula. And some of the other important formulas of this chapter are conductivity formula, molar conductivity formula and the formulas related to Kohlraasch's law. So to find out the limiting molar conductivity of NaCl or calcium chloride, you need to use these formulas. The third chapter from physical chemistry is chemical kinetics. From this chapter, you will get the numericals related to first order kinetics or its half-life, first order half-life, or you may get another important formula is to find out the energy of activation EA. These are the important formulas from these three chapters. Now we will see some of the important numericals related to all these three chapters. So this is the numerical to find out the molality of urea. Question and solutions I have given. Then another important, they may ask you to calculate the mole fraction. So this numerical is to calculate the mole fraction of ethylene glycol. So solutions has been mentioned. Then the problem related to Henry's law to find out the mole fraction. This is also very important. Then we have some of the numericals related to relative lowering of vapor pressure. So this question is from relative lowering of vapor pressure. Then we have one more numerical about relative lowering of vapor pressure. Then we have a question and answer for elevation in boiling point Another question from elevation in boiling point to find out the molar mass of solute. Then this question is to find out the molar mass of solute related to depression in freezing point, related to freezing point depression constant. One more numerical related to the third colligative property, depression in freezing point. Then these are the numericals from the fourth colligative property, that is osmotic pressure, to find out the molar mass. Two examples I have given here. Then we have some questions from electrochemistry chapter from the concept Nernst equation. First, from the given data you need to find out E naught of a cell. Then use the Nernst equation formula, substitute the values and find out the EMF of the cell. One more related question from the Nernst equation. In this question, E naught of a cell directly given. Just write the formula and substitute the values and find out the electrode potential or EMF of the cell. Then we have some questions related to equilibrium constant Kc. In equilibrium constant Kc, you must learn how to find out the anti-log. One more numerical is from equilibrium constant Kc. This also very important to the exam. Then we have question and answers from Gibbs free energy, delta G naught. Delta G naught is equal to NF E naught of a cell. Two examples I have taken here from this delta G naught concept. Then one more important question from this chapter is to find out the conductivity of the cell. This is one example. Then they'll ask you to find out the molar conductivity also. Molar conductivity numericals also important from this chapter. Apart from this, you also focus on Faraday's numericals. Those also very important to the exam. Solution chapter you be perfect first. Along with solution chapter, either electrochemistry numericals or chemical kinetics numericals, anyone if you are perfect, you can able to manage this numerical section. So these are the numericals related to chemical kinetics. So we have from first two examples to find out the half-life of first order by the formula T half is equal to 0.693 divided by K. K is rate constant. The three numericals related to T half. Then we have a numerical related to first order reaction. K is equal to 2.303 divided by T log of initial concentration divided by final concentration. Then last two numericals related to find out the energy of activation, log K2 by K1 is equal to energy of activation EA by 2.303 R T2 minus T1 divided by T1 into T2. So we have given here two examples. So these are the very important numericals you may get in the coming exams. Thank you, students.